Hello, question 3 gives us a graph of velocity versus time. And the graph is this one here. This is the graph. And we have to translate that into position versus time. So x versus time. I'm sorry. And in order to do that, obviously the question provides a couple of answers, but this is the only right one. This is the translation. And why is that? That is because we see that here the velocity is going down, right? The velocity starts at a high point. Let's say it starts at 100. It starts at a high point, and you imagine it's like something going at 100 miles per hour, and it goes at a high speed. So in a range of time, in a small range of time, you move a lot, right? That's basically the idea of velocity, right? It's delta x over delta t, and since your delta x moves a lot, right? If your velocity is high, is because your delta x is high, right? Delta x is high. I'll put it like this: it's high. So we have this, this slope, which is a high slope. I'd call it, since we have this 100, I'm gonna say it's a slope of 100. Obviously, this is, just theoretical. But as the velocity decreases, we see how the slope changes, and until a point it becomes zero, which is when it reaches here. After it becomes zero, the velocity is negative, which means that your position is going to be going down, back, until it reaches zero in your position, until you fully stop, right? Your velocity determines the rate at which you're going. So at some point you're going to stop, and you stopped at zero. You can That's basically the idea of this exercise.